Hello everyone, this is another video for the Ansys tutorial. In this video I will consider a plate having a hole in between, so from this we can calculate the stress concentration. So I have taken one example of a plate which has a dimension 60 mm and a 40 mm breadth, and the diameter of the circle is 10 mm. Elastic constants is a 200 gigapascal and Poisson's ratio is 0.3. Here the force is given 2000 Newton. So by applying in the Ansys, we will convert it into the pressure. Pressure will be the 2000 Newton divided by area. Area will be 40 mm into, we will consider the 1 mm thickness. So 2000 by 40, it will be 50 Newton per mm square we will consider. Okay, let's go to the Ansys. I will change the name. We'll change the name of the example plate with hole. So let's start the experiment in Ansys. I will select a structural. Here we are selecting the element as a solid quadrilateral 4 node. Okay. Here just one change is required. Now options. Here we'll change the plane stress with respect to the thickness. As we are taking the thickness as 1, so it won't affect much, but if you are taking more, and then it will affect. In the real constant, add the element. Okay, and thickness we are considering as a 1. Material will be steel, isotropic, 2e to the power 11, 0.3. Okay, modeling, create. We are creating the areas. A rectangle with the dimensions we will specify. Or we can take a symmetric plane divided by 4. We will divide this plate into the 4 parts, so it will be easy to analyze and all. So take by corners, leave it 0 0. From origin we will take width will be 30. So we are taking in meter, and this will be 0.02. We have divided. This is the 20 mm and 30 mm. Okay, it will create. Now it's required. Now circle is required. Solid circle. I leave it 0 0. So from origin itself it will generate. Then after the radius it's mentioned 10 mm. 10 mm the diameter. So for the radius 0.005. Okay. Now we need to subtract this. So go to the boolean subtract areas. Select the first area from which we have to subtract. Okay. Now select the second one. Okay. Now see, you can see the required model. Now it's done. Modeling is done. Now we have to do the mesh tool. We require here the meshing for circular type. It's maybe somewhat difficult, so we'll do the smart size and we will go with the fine mesh. Okay. You can see the fine mesh is done. And now we can go with the solutions. Analyze type, new analysis. Keep it as a static. Define load. Apply structure. For displacement, we will apply for the symmetric boundary layer. As I told that we are taking the 4 symmetric parts. Just then after, we will analyze the simply by combining 4 parts. So on lines, symmetric boundary on lines, select the lines. Okay. Symmetric boundary conditions are applied. Now as I told that in place of the force, we will apply the pressure on the line. Select the line. And as I told, it will be 50. As we calculate the pressure in Newton per mm square, it will be Newton per meter we require. So 2000 divided by 0.04. 0.02 as we have selected for that particular thing, that particular part. So 0.02, it will be in 1 into e raised to 5. Okay. Oh, sorry, it will be in the negative. We can delete it. Select the line. It will be deleted automatically. Now we have to apply again the pressure on lines. Make sure you are applying on the particular direction. Negative. Okay. Now it's done. Now we have to solve. Go to the current ls. Okay. Solution done. Okay. Successfully completed. Now you can see it's here the boundary conditions are seen, and here the pressure. And you can go with the general post processor that plot the result, contour plot, nodal solution, and you can go with the displacement vector sum, as we have to consider the displacement in every direction. This will be the vector sum of the displacements. And now you can consider the whole plot. So for that you can go with the style, symmetric expansion and periodic cyclic symmetry. It is a 1/4 dihedral symmetry. Okay. Okay, you can see here this it is a considering all other parts also. Now you can also see the nodal solution in the stress. It will be the one mysis. You can see in the one mysis stresses. Okay. Here we have selected the first plot. So go into the last set. There the results it will show. Okay. Now you can see the one mysis stresses. It's seen. Okay. Plot replot. You can see the properly the one mysis stress. Okay. Now in this video I can show you how to animate any model. Just go to the animation and deform results. Go to the stresses or deform displacement also you can take, but in this example I will take a one mysis stresses. Do OK. You can see easily the animation of the plate having a hole. You can here decrease the speed and increase the speed. Thank you everyone. This was for now, and be updated for the upcoming videos. Thank you.